So here the way I'm going to do this problem is to just consider a list of scores, x1 through x10. And again, this I'm just arbitrarily using 10. Could be any number. And we're told that scores are going to be adjusted by this formula 0.8x plus 20, which means that each quantity in this new list would be 0.8x1 plus 20, 0.8x2 plus 20, so on and so forth. And the question is, what happens to the standard deviation once you do this adjustment? So the original standard deviation is 20. So if the original mean was m, what will happen is the new mean would be 0.8m plus 20. Because you're going to be adding all these up, dividing by a number of terms, and we'll see you'll get a multiplier of 0.8 on the mean, and 20 you're adding to the same. So standard deviation is the way to compute this. You just need to know qualitatively how it's done. You're looking at the deviations from the average, and you'll see that the deviation would be 0.8m plus 20 minus 0.8 x1 plus 20. You'll see that 20 will drop out. It's going to be 0.8 times m minus x1. So originally, the deviation was m minus x1. It's 0.8 times m minus x1. Same thing for the other ones, 0.8 m minus x2. And you will get this multiplier for the standard deviation. So it's simply 20 times 0.8. If you want to see it a little bit more in the standard deviation formula, would be you would take this deviation, square it. You don't have to technically do any of this. And then you do for all of these, and then divide by number of terms, so 10, take square root, and you'll see that the 0.8 square will factor out. You'll get a 0.8, and then inside will be the original standard deviation. Remember, I just chose 10 to be the number of points, so that would be the standard deviation here. This is what's given to us as 20, and that's why you get the multiplier of 0.8. So if you already know the result, you can just apply it. You don't have to do any of this, but I did it just so you can visualize why it's multiplied by 0.8. So the answer is 16, which is choice B.